Okay, so the final exam, as you know, is in 8 days, December 12th, 3:30 to 5:30, or 6 to 8, either in here or next door, depending on where you fall in the last name spectrum. This is the, no. Remember to bring your ID card, and you can bring 2 sheets of notes. Also, your PS11 is due tomorrow or Friday. Remember, for PS11, you hand in the zip project, and if you're doing extra credit, you hand in a PDF that says what your extra credit version of the game does differently that you think deserves extra credit. So that'd be an extra submission. Just one zip file, though. Any questions or problems about anything before we proceed? Yes?
On the first slide, it says that everyone should go to room L104 at 6.
Yep.
So is that the one for no final exam we have to go to?
Oh. Yeah. Yeah, I see how that could be confusing. No, if you're taking the exam at 6, it's in here is what that means. Not, yeah. Anything else? Okay, so this set of slides here, it goes on to go over a bunch of, basically a bunch of review slides for the semester. And my experience is it doesn't make for a very interesting review to go over the review slides. They're more for you to look at later. Instead, what I want to do is work on a midterm, a final exam from the past. So we'll work through it together, and hopefully it will remind you of questions you want to ask, not just about the exam, but about anything. So let's get started and see where it leads us. Okay, so the first question here is similar to the question you had on the midterm. We've got to write down a Java type name that meets the criteria. So that first one says an object that permits extracting words, integers, and floating point numbers from files and strings. Okay, what would that be? Right, so that's a scanner. Okay, how about a collection of strings guaranteed to contain no duplicates that can be accessed in lexicographic order? I'm hearing sort of lots of takes. Anyone brave enough to say their opinion out loud? Okay, so tree set. Okay, that would get you half credit. Yeah, tree set of strings. Now, what are the clues that we're talking about a tree set here? Okay, so lexicographic order, that's essentially an extension of alphabetical order. That's one clue, and we know that if you're considering between tree set and hash set, tree set would give up, you can iterate through it in lexicographic order. What makes you think about sets, besides the fact that it says a collection?
No duplicates.
Yeah, the no duplicates thing suggests that we're talking about a set, and then it's going to be a set of strings, so that's where the string comes from. That makes sense? Okay, the top level window of a GUI application that appears when the application is launched. Yep, that's the J-frame. And an index collection of integers. So if I stopped right there, what could I be talking about? An array. It's one thing. What else? An array list would be an index collection, and so would a linked list. Those are at least 3 things that would qualify if we stopped right there. But it says it supports efficient insertion and deletion. So how does that narrow it down? We've got 3 possibilities, and we say it supports efficient insertion and deletion. Yeah, a linked list. We saw this last time, that inserting into the middle or beginning of a An array list is inefficient, and for an array it's really impossible because you can't grow the size of the array. But linked list is made for that sort of thing. And it's a linked list of what?
Integers.
Yeah, a linked list of integer. So obviously I like asking this type of question, so you can rest assured there'll be something like this on the final. Any questions on that one before we move on to the next one? Okay, so look at this. I give 6 statements. So in the first line, we're creating a hash map that maps strings to integers. We're calling it map. And then we put 5 key value pairs into the map. So you look at those 5 calls to put. And then the question is, I give 4 expressions and ask you what the value is. So what would map.size be? Okay, how many think 3? Right? How many think 5? Okay, the rest of you think something else? Okay, so the correct answer is 3. So why, if we're doing 5 puts, do we end up with only 3 pairs? Yeah. Right. What he said was you can't have duplicates. So we do the A, the B, and the C. So we get to this point right here, the map is already of size 3. When we do this, we're just replacing what B was mapped to before. Before it mapped to 2, now it maps to 4. So the size is still 3, and the same thing happens here. Put the A in, you're just replacing the value of A with a 5, where previously it was a 1. Okay? So when you do map.get of A, once you understand that much, the rest falls out. What do you get when you do map.get of A? 5, because that was the last one. And then for B, it's going to be 4, and for C, it's going to be 3. Okay, makes sense? Would this been any different if instead of a hash map, we'd used a tree map? If I just changed that to tree map, would any of the answers have been different? Yeah?
You would be able to have, like, for B, you might have had 2 and 4 when you get it, because you have multiple.
Okay, so he's suggesting that if there's a tree map, when we insert, like, we might get 2 elements out when we looked up B or A. But in fact, that's not how it works. The tree map would behave identically to a hash map. The only difference you'd see is that when you iterate it over, you're guaranteed to get them out in the ABC order. Whereas for a hash map, who knows what order they'd come out in. Anything else? Okay, so we've talked several times about the runtime stack model, the stack and heap model, the memory model of a running Java program. So this has to do with that. So the table shows 4 kinds of values that a running Java method has to keep track of. So it needs to know the values of its parameters. It needs to know the values of its local variables. It needs to know the values of the instance variables that it has to access. And it needs to know the value of this, the object on which it was invoked. And we're supposed to, what we're being asked here is that value kept in the stack frame? And this is important. The value of a variable that contains an object is always a reference. So when I say, if a variable is a string, its value is a reference. Okay? The reference is to the heap, and the heap will contain other stuff, but I'm talking about the reference as its value. So having said that, are parameters, are the values of parameters to a method stored on the stack? Okay, I'm hearing some yeses. The yeses are getting a bit more confident. Okay. What about local variables? Yes. So the stack exists to store the values of local variables and parameters. So what about this? Yes, because it's the implicit parameter. It's still a parameter. So for all of these, the answer is yes. That's just why we have, every method invocation has a stack frame, and it contains parameters and local variables. What about instance variables? Okay. Where are the instance variables going to be? They'll be in the heap. The idea is you'll have a stack. The stack will contain a stack frame. In the stack frame will be stored this. This will refer to the heap, to an object on the heap. And in this object, you'll find the instance variables. So to find an instance variable, you'll have to go to this and then come out to here to find the instance variable x, for example. Okay, there are a lot of complexities to the runtime memory model, but at a minimum, you need to know what are stack frames for and what's the heap for. Any questions I can answer about that? Yeah?
So what exactly is the difference between a stack and a stack frame?
Okay. Well, let me see if someone else can answer that. What's the difference between a stack and a stack frame? Yeah?
Is a stack like the whole thing and the frame is just like that one object?
Okay, so the stack is the whole thing, so the data structure, and it contains stack frames. So a stack is made up of stack frames. And when a method is called, its stack frame, a stack frame for it, is pushed on the top of the stack. And when it returns, that stack frame is popped. So at any given time, if you have 10 stack frames, that means you're 10 levels deep in the chain of method calls. Any other questions I could help with? Okay. Okay, in instance variables, we decided the answer was no. Okay. Suppose that you want to have a GUI that has one component in a large central area and the remaining components around the edges, sort of like what you see here on the screen right now, where I have the large central area here, and then I got stuff on the edges up above. There's only one edge with stuff, but what kind of layout manager are we talking about? Right, that's a border layout. And suppose you want your components to be in a rectangular grid, all the same, all the components are the same size. Right, that's given away by the question. That's a grid layout. I could have said here, components are to appear along the borders, and that would have given the other one away too. But that's not that hard of a question. Okay? Does that inspire anyone to ask any questions about that? Yeah?
What sort of layouts are there in the layout?
What kind of layout managers are there?
Yeah, aside from border layout and grid layout.
Well, the ones we looked at were flow layouts, which are left to right or right to left, or this way. Box layouts, which work in either direction. There's something called a grid bag layout, which is kind of a complicated, but very, since it's complicated, you can do fancy things with it, but we didn't look at that. Yeah?
So, if you're using border layout and you put multiple things in north, does it just go from in order left to right? Is that how it decides lay them out?
Well, so he's asking if you have, so let's say you create a window and use a border layout, and so here's the center part, and you start adding, if you add multiple things to that, what happens? And I believe what happens, I have to try it to be sure, is all you're going to see is the last thing you added.
Oh, it overwrites it.
Yeah. So what if you wanted multiple things in this area? What would you do? I just pointed with my pen at the screen, but you can't see it. In this area here.
Would you put a border within a border?
Okay, how would you do that? For example, what if you wanted to have a grid where I put the X? You want a grid in the center part. So you want to add a grid as the center part of the border layout. What would you need to do? Yeah.
You create a new border layout and then set that border layout into the center of the
Okay, so create a new J panel, and you said give it a border layout, but I would say give it a grid layout, sort of a verbal typo, and then you add that J panel to the center. So you have a border layout that contains something that's managed with a grid layout. So that would be just like Lights Out was like that, and so was, Tic-Tac-Toe was like that. About all our examples were like that. Trying to think of the other one. Connect Four. Yeah, we did Connect Four. Any other questions? Okay. I'm going to erase that big circle there. Hold on a second. This next question, so this one you have to think really carefully about. I is an interface and A is a class. Okay, so we got that. B is a class that extends A. C is a class that implements I, and D is a class that extends B and implements I. Now, I'll give you some advice. If you see a question like that, and you probably will, draw a diagram to show how these five things interrelate. So we know that A is a class, so I'm going to draw a... Now, hold on a second. I'm going to draw a box up here and call it A. So that's the class A. And I is a interface, so I'll draw it over here. I have to remember it's an interface, not a class. And then B extends A. So I'm going to draw that like this. Okay, B extends A. And then C implements I, so I'm going to, C is a class that implements I, so I'll do that. And then what should I do with D? Yeah, we're going to have D here that implements that, extends that class and implements that interface. Fine. I hope I got all that right. So that way you can at least glance at it and see how things interrelate. So you can see from this, for example, that a D is a kind of a B, and a B is a kind of an A. So you can think of that as a kind of, or is a. A D is also a kind of an I. On the other hand, there's no relationship between the C and the D, or between the B and the C, or the A and the C for that matter. Okay, so we've got these five things, and we have this method here that expects two parameters, an A and an I. An X and Y. X is type A, I is a type Y. And we're asking, whether each of the following method calls are legal or illegal. How can you tell? This first one here, it says, okay, I'm passing a new A as a first parameter, and a new D as a second parameter. So for it to be legal, what has to be true? What does X have to be for the call to be legal? What type of thing does X have to be? It has to be an A, or a kind of A. All right, and clearly, it says right here it's an A, so we're good there. And what does the Y parameter have to be, the second parameter? Right, it has to be a kind of I. Well, is a D a kind of I? Yes. Yeah. So the answer here is legal. Okay? What about the next one? Is a B a kind of A? Yes. Yeah, and you can look at your diagram here and see that. And what about an A? Is an A a kind of I? No. So that's illegal. Okay? What about the next one? Legal or illegal? Okay, what's wrong with it? C is not an A, and a B is not an I. So there are two things wrong. And what about the last one here? That's good because a D is a kind of an A, and a C is a kind of an I.
D is an A and an I, though, so.
Yep, it's both. But D is both a kind of an A and a kind of an I, but all that matters here is it's a kind of an A. So that's legal. Now, what if we did this? What if we said F of new D? What if you passed two objects of type D. Is that okay? Yeah, because it's both an A and an I. What if we did this? What if we declared, we said D equals new D, and then we did F of D and D. We passed the same object. Up here, I passed two different objects of type D. Down here, I'm passing the same object twice. Does that make any difference in whether it's legal or illegal? Yeah, it's the same situation. That object, that little d there, is both it's a kind of an A and it's kind of an I, so it's good. Okay? I don't want to rush off from this one. Any questions I could answer here? All right, see what's next. Okay, this is like from the midterm, evaluating expressions. And in these kinds of questions, I always want the answer to be a Java literal. So something, a literal will be something you could write directly into a program, like to or true. So I'm asking here, is system.in an instance of object? Well, what's the type of system.in? What is this thing here? Does anyone know? You've been using it all semester. Well, that's what it does. System.in is for reading input in the program. But what, is it a double? What is it? Yeah?
Is it input stream?
The thing, I have to admit, I'm not sure either. It may be an input stream. It may be an input reader. I don't know. So how can you possibly answer this question? Yeah?
Because everything in Java is some sort of object.
Right. Everything in Java, as long as it isn't a primitive, every kind of object is an instance of big O object. Every class extends directly or indirectly the object class. So as long as we know that system.in is an object, and what else could it be? Because it's not an int or a double or something. So the answer is true. Now, if I said system.in instance of input stream, I wouldn't know what to write. Typically, if I don't know what to write as the answer, I don't ask it as a question. So, all right, what about this next one? 5 greater than 3 and 6 less than 6. False. So it's just a matter of knowing what that and operator does. Now, this one is sitting here. This is the exam from 2014. I don't think I talked about the ternary expression. Did I give you reading in ZyBook about it?
You used it in a program, but you never had us to read about it.
So, right, I guess it's never too late to learn something new. I'm not gonna put it on the final because we didn't really talk about it. But let me explain about the ternary expression. So the first thing is, why is it called ternary? What's ternary mean?
It takes turns.
Takes turns? Yeah? No, that's not the answer. Yes?
Well, I was taking the definition of ternary of 0, 1, and 2, so there's 3 options.
Right. So ternary, it's kind of the same kind of thing as binary. Binary means two parts. Ternary means it has 3 parts. And the 3 parts are this thing right here, this thing here, and this thing here. And the punctuation is the question mark and the colon. So it looks really weird. But the question mark and the colon are there to break it into 3 pieces. The second thing is, okay, it's a ternary expression. So what does expression mean? Yeah.
It's not a complete line of code. It has to be implemented within something else.
Okay, it's not, an expression, he said it's not a complete statement. He didn't use that word, but it's different from a statement. So a statement has some side effect. It causes something to happen. An expression has a value and a type, something you evaluate, like 2 plus 5. So I wouldn't ask you what's the value of this while loop, because while loops don't have values, but a ternary expression does. And the value of this expression is determined as follows. This first thing here has to be a Boolean expression, has to have a value of true or false. if the value of the thing I circled is true, then the value of the entire expression is this first thing. And if the value of that Boolean is false, then the value of the entire expression is the second thing. So what is the value of this ternary expression? 6 is less than 8, so the answer is 1. Okay? Now let me show you where I tend to use ternary expressions. I didn't start using them until late in life. And so if you don't like them, I didn't like them for like 40 years. That's maybe 30 years. So I find myself doing something like this. Okay, I declare a variable, int n, and then I write if n is less than or equal to 0, n gets 7, else n gets 8. And I left the braces out just so I didn't have room to write them. But if I put the braces in, and the way I do indentation, I'd have 1, 2, then the line for the brace, that's 3, then 4, another brace, the else, another brace, n equals 8, 9 lines of code. How could I write the same thing in one line with a ternary expression? Yeah, back there.
N less than 0, question mark, n equals 7.
Okay. Well, we can make it simpler than that. So I want to write the expression in this box right here. So the ternary expression would be n less than or equal to 0, question mark, 7 colon 8. So what that does is it evaluates this expression here, and we decided what's the value of that expression? Depends, wait. This is bad. Let's make this m. Okay? So if m is negative, what's the value of the expression I circled going to be? It's going to be 7, and what will happen to n? Its value will be 7, right? 7. So it's just like any other expression. We evaluate the circled expression. If its value is 7, we store the 7 in n. On the other hand, if m is positive, the value of this circled expression is 8, and 8 will be stored. So the reason I like them nowadays is just because it saves a bunch of lines of code. Yeah?
I know exactly on the final already, but is there another step above ternary?
You're asking, is there a step above ternary, like quadrary or something?
Yeah, something like that.
No, this is as far as it goes. Now, you could, if you wanted to, make, say, this expression here be a ternary expression. But I haven't fallen in love with that yet. Then I would use a switch or an if. Okay, that's totally an aside, but at least you shouldn't run and scream when you see a ternary expression. You know what it means. Any other questions about that? Yeah.
So for the actual example in the exam, would that expression be an assignment for like a string s, I'm guessing?
The last example?
The one that's on the exam, where the answer is 1. I'm just saying, like in the one you gave as example, you did int n equals that because
Yeah.
it's an integer. Would it be like a string s being assigned that expression?
Right. I was just showing that you can use the ternary expression in an assignment, for example, or anywhere, as a parameter to a method. But yeah, the answer up there would be 1. You could say string s gets value of ternary expression. Okay, what about this last one here? This one here. Okay, got some votes for false. Any other votes for true? What does double equals tell you when you compare two objects? Right. You're basically saying, do they have the same reference? Are they the same place in memory, which means they are physically the same object? Okay? How do you know, even though these two expressions are identical, new scanner A, how do you know that they will not be the same thing in memory? Because you're calling new twice, right? Each call to new creates something new in memory, and so there's no way they can be the same. So that's going to be false. Okay? Now, I looked at PS10 and I saw almost everywhere I looked I saw people comparing strings with equals, double equals and not equals. And sometimes that'll work because of the way string literals are dealt with, but sometimes it won't. So if you want to know whether two strings contain the same characters, don't use double equal, don't use not equal. What do? Dot equals. I have a suspicion that there's a setting I could have been setting all these years in Eclipse that would flag doing this for strings as a warning. I need to check that out because that would save a lot of trouble for a lot of people if that were the case. All right. Any questions on F before we move along? Yeah.
Just about like dot equals.
Mm-hmm.
What's the difference between dot equals and dot content equals?
I'm not sure. Okay, so you've noticed as I've been programming in front of you that I try to do dot equals for strings, and Eclipse wants to make it dot content equals for some reason. And it must be a relatively new method because that never happened to me before. And I have to admit, I never went to the trouble of looking up what dot equals does, what content equals does. But I think I understand. Let me put it this way. Can you do this? Suppose S is a string. Could you ask, does it equal a scanner? What do you think? No one seems really certain, but I heard more no's than yeses. But the correct answer is yes. The parameter, the second parameter, the parameter to dot equals can be any object whatsoever. So dot equals, you say some object dot equals, you can pass any other object to the second parameter. So what would happen? What would be the answer if you compared a string to a scanner using dot equals? False. Unless they're the same type of thing, the answer is going to be false. With content equals, the second parameter has to be a string. I think that's the important difference. Any other questions? Okay. If you look back on this on the video or whatever, I'm just looking at the slide now. It looks actually it doesn't look all that different from some things that we have to grade. So, and lo and behold, well, I did screw up a little bit. I did put this mark right here in the box. So just try to keep your answers in the box. Doesn't much matter what you do outside the box. Okay, 2 class definitions. So this is another thing having to do with inheritance. And so let's draw a picture. We've got A and B, and what's the relationship between A and B? These 2 classes. Yeah, B extends A, so we'll make a note of that here. Okay, and let's see what we're doing. So we got this method F that calls G of 2 and turns it into a string and returns it. That's what F does. And what G does is square its parameter. Okay? And down here for B, all we're doing B is overriding G, so instead of squaring its parameter, it cubes its parameter. Oops. That's not what I wanted. Okay? So what methods will B have? Certainly it'll have a method G. Will an object of type B have a method F? Yeah. Okay, so unfortunately we have to scroll past that. So here are 2, okay, I'll give you 2 pairs of statements in each box. In each case, I have a declaration like, declare a variable and assign it a value. And the second is a method invocation. And so we've got to decide, is the declaration invalid or valid? And if it's valid, I want to know the value that's returned by the method invocation. So it takes a while to get your head around what I'm asking. So let's say we create a new object of type A, and we store it in that variable A, which is of type A, and then we call F on it. So is that legal? Yeah. Sure. Nothing, I can't see anything wrong with that. We create the object, we store it in a variable of the same type, and then we call F. Well, what will that return? string containing 4. Yeah, because we're going to take the 2, call G with 2. Here I am pointing at this again. You get the idea. I'll point here. Well, and the people watching the video can't see it. But we call G with 2, we get a 4 back, we append the empty string, we get a string. And that's the string 4. So the answer here would be 4. Okay, what about here? We're creating an object of type B, but storing it in an object in a variable of type A. And then we're calling f on it. Is that okay? Is it okay to store an object of type B into a variable of type A? Why? Yeah, B is a kind of A. So that's good. What's returned when we call, when we do the method call here? A.f. Okay. The thing is it's 8. Okay? And why is it 8? Because the place you can get confused is you can say, okay, since it's stored in a variable of type A, it'll behave like an object of type A. But it won't. Even though this object is stored in a variable of type A, it is still a B object. And so it's going to behave like a B object. And B objects, the way they work is if you call the f method, what happens? It calls G of 2 and it turns it into a string. But what's G of 2 in this case going to be? It's going to be this guy down here, which cubes its parameter. It's overridden there. And so you get an 8 back and turn that to a string. You get the string 8. So any B object, no matter what kind of variable it's stored in, is going to have this f method and this G method. So in other words, which method G is called depends on what type of object you're dealing with, how the object was constructed. So we decided the answer here was 8. Okay, what about this one here? We're taking an object of type A, we're creating an A object and storing it into a B variable. Okay? What'd you say? Can't do that. Why? Right. A doesn't extend B. Right. This arrow here is one directional. So you can create a ship and store it in a participant variable, but you cannot create a participant and store it in a ship variable. For several reasons, actually. But okay. What about this next one here? Oh, this is invalid. We create a B object, store it in a B variable, and call B.f. Yeah, it's exactly the same as this one here. So typically, I think we would see people, this one, the second one would be the stumbling block, I think. Trying to know what happens. The behavior of the object somehow changed because it's stored in a variable of a different type. And no, it doesn't lose its identity when you do that. Any questions I could answer about that?
So even though it says like .f there, is the reason why it's 8 because it's overridden again?
Okay, it says .f where? Which one you talking about?
For the bottom one, it says B.f.
Okay. Okay, and go on with your question.
Is the reason why it's 8 because it's like overridden earlier?
Right, well, yeah, we call B.f, which means we execute this method, which calls G on that same object. And it's called G on the same object, and it's since it's overridden for objects of type B, we use that one for G. Yeah?
So if that's the case, we're using that G, should it just be the integer 8 versus the string 8 like we usually see?
Well, 8 is what was integer 8 is returned by G, but then up to F,
Right. Okay.
we immediately turn it to a string.
All right. Thank you.
Okay? Any other questions? Yeah.
With the second one, is there any fundamental difference between that object and the last one that we created? Like say it were to be different classes with more methods, or is that exactly?
Yeah, no, this new B and this new B create objects that'll behave just the same. What we do with them after that doesn't affect their behavior. Any other questions? Yeah.
For the second one, if we wanted to specifically use the G method out in A, do we have to like write superfund it to use?
Okay, you're asking, suppose I specifically wanted to call right here, I wanted to call a.f, but somehow make f use the original g. There's nothing we can do to cause that to happen. The only place you can use super is inside the class itself. And we're sitting outside the class, so we can't affect how that method f is going to behave, which is as it should be. We shouldn't be able to somehow mess around with the behavior of method when we're completely outside the class. Any other questions? All right, here's another runtime memory question. So every time a running Java program uses a new operator, an object's allocated on the heap. And if a program ran for a long time, and that was the whole model, eventually you would run out of memory. So how does Java avoid running out of memory? And this proposes two ways. One of them is the way, and the other isn't. So one way is the objects allocated by a method, so the objects created by calling new, are automatically removed from the heap when the method returns. Is that what happens? No. Why would that be a phenomenally bad idea? After all, when the method returns, stack frame for it's thrown away. So why not throw away all the objects it created? Yeah?
You can't make any other calls to the object.
Okay, you say can't make any other calls to the object. The point being, the method, the purpose of calling the method may have been to create the object and to return it. And if you then turned around and got rid of it, that would be bad. So that's not how it happens. What about obsolete objects are automatically removed whenever the heap starts to fill up? Yeah. Now, there's a lot that goes into that. That's called what? That's garbage collection. And I'm having trouble remembering what point I was going to make. Oh, there's a lot that goes into that. Detecting whether an object's obsolete. The technical definition would be if there is no way, usually you're going to have a reference stored on the stack, and it's going to go to an object, and maybe it has a reference to another object, and it has a reference to another object. So to decide whether this object's obsolete, you've got to determine, is there a way to get here by following a chain of references from the stack? And there may be multiple ways to get to an object. There may be multiple references from the stack. So a garbage collector has to take all that into account and figure out, is it truly not needed anymore? When the garbage collector can determine that an object isn't needed anymore, then it wipes it out of the heap and then can reuse the space. That's a very complicated subject, though. Okay. Here are 4 pieces of programs. There's a keyword, there's a type, another keyword, a comment. So this is kind of an esoteric question. Now I'm looking at it. One of them is an example of information hiding. Another is an example of a generic class. Another is used in inheritance, and the other is an example of data abstraction. Okay? So I don't know that I've used all those terms this semester, but let's see if you can answer the question anyway. Which one would be an example of, is related to inheritance? Extends. Okay. All right, what about that next one? See, we've done inheritance, so I'll scratch that out. Right, I've used that term, so this is a generic. So, okay, what about private? Yeah, the use of private instance variables is often called information hiding. In what sense are we doing information hiding when we use a private variable? All right, so he's saying we make the variable inaccessible to the outside world. We're basically hiding the variable from the outside world. They don't need to know about it. And even if they do find out about it, they can't do anything with it. And that leaves data abstraction here. So why is that called data abstraction? First of all, why is it abstraction? Yeah.
Can you start talking about what the idea behind the class is instead of how it does it?
Okay, that's perfect. He said that comment talks about how to, what the class is for, how to think about the class, as opposed, which is an abstraction of the actual class and all of its details. Remember, abstraction is ignoring details to take taking a simpler view of something by ignoring selected details, and that's what we're doing there. If we're looking at a ordered pair class, it's going to have instance variables and methods and such. That just boils it down to what you need to know in one comment. That's abstraction. And since it's abstraction applied to a class, that's data abstraction. It has to do with new data. The Java dot comment for a method would be an example of what's called procedural abstraction. Procedure is sort of a synonym of method. Okay? All right, let's take a quick break and then we'll look at some more of these. Okay. All right, this goes back to a pre-midterm question. I described 4 problems, and I want to know what kind of loop would be required. By what type, I mean accumulation, searching, or optimization. So we got to multiply together all the numbers from 1 to 1,000. All right, that's accumulation. You're combining them all into a single answer. Find the longest line in a scanner. An optimization loop, because we're looking for a superlative member. Identify a 6-character string that appears in an array of strings. It's searching. You're just looking for a particular thing. calculate the total length of all the strings in a list of strings. Accumulation loop, you're just adding up the length of all the strings to get an overall answer. Okay? So you sounded a lot more confident about that than the questions about inheritance. So that's encouraging to a teacher. But I shouldn't blow off the opportunity to ask questions. So.
Like the tricky part about the midterm was that it could have been multiple.
Yeah.
So will it only be like a single one, or could it be the option that it could be multiple?
You mean like you use an A twice?
No, when we have last optimization and description was multiple. It was like both could be used to describe a certain task.
I don't know. I haven't made it the exam yet. Any other questions? Okay. Okay, this has to do with stuff we've done very recently. So these are all trues and falses. Merge sort is faster than selection sort. Now suppose that was the whole question. Suppose I took that out. Merge sort is faster than selection sort. What would the answer be? It depends, right? All I told you was that for large arrays, merge sort was faster. For short ones, you don't know. It could be the opposite. So what's the answer? Well, I just told you the answer. True. Okay? As presented in class, selection sort is recursive and merge sort is iterative. Yeah, what you may recall is that selection sort and insertion sort just use loops. Although thinking about it, never showed you any code. I sort of used the word loop. But merge sort I definitely said was recursive. So that's false. It's backwards. If selection sort takes 1 second on an array of length 1 million, it will take about 4 seconds on an array of length 2 million. Okay? Now, where did you get that answer from? What did I tell you? Right. It's a quadratic algorithm, which means if you double the length of the input, you quadruple the time it takes to do it. So that's what's happening here. We're doubling the length of the array. The sort takes 4 times as long. So that's true. And the same question about merge sort. False. About how much time would merge sort take if you double the length of the array? Okay, here are some tentative answers there. Would it be 2 million? It would be close. It would be a little worse than 2 million because merge sort's n log n. And what I want you to know about that is it's just a little worse than linear. So it would a little more than double. But it does not quadruple. So that's false. There's a lot more to know about this, but that's for another class. Just the basics here. Any questions I could answer? What about quicksort? Is it recursive? Yeah, so quicksort and merge sort are faster on average than selection and insertion for large arrays. And selection and insertion are iterative, and the other two are recursive. Okay, this should be easy. So adding a photon mine to the asteroids game, I actually did that in lecture. Sort of. From what class should photon mine extend? Yeah? Participant. So that is not you're not going to find that on the CS 1410 syllabus anywhere, say a statement saying that students should learn what classes are used in the asteroids program. But over the years, I've started asking questions about that project on the final, just to make sure that if you're in a partnership, that you actually helped. When we find students, when they can't answer that question, it means they really didn't participate much. Pun intended. Oh, I hate this question. It's awful to grade.
Take it off the slide.
Well, it won't be on, and these questions won't be on the final, but here it is. So What are some ways in which event listeners were used in asteroids? What's that? Okay, so there's like key press, what were they called? Key press. Those are the method name. Is it just like key event or something? All right, so there's key event, there's mouse event. Okay, see, that's why I hate it. I can't remember what the program has. What else did it have? Action listeners. In connection with timers. It had participant countdown timer that called countdown complete. That was a kind of listener. Anyway, we ask questions like this, and I end up accepting anything within reason, which is another reason I don't like the question. But all right, let's move on. Okay, now with the type of each of the following job expressions. It's the same kind of question that was on the midterm. So what type of thing do you get back when you call math.max on 1 and 2? Right, an int. What about that one? You get a char back. What about that one? That's a Boolean. It's just telling you, is there a next token? And what about the last one? It's asking you to give the next token. You get the next token, which is going to be a string. Okay, that's pretty straightforward. What the heck?
I think you're
Oh.
giving the value.
All right, this was the type, and here's the value. I already asked a question like that. Okay, this was from 2014. Obviously, my test making skills have improved. So what's the value of this one? 2 H, and sometimes we're picky about writing the literal single quotes. Is there a next one? True. What is the next one? This. Okay. All right. I'm just asking, what could I put in the blank that would cause the expression to throw an exception? This also has many, many answers, but there's usually one that I had in mind that's sort of natural. So what would cause that first expression to throw an exception? Right, you could ask, what's at index 5? Like if you stuck a 5 into that box right there, that's not a valid index. You get an array index out of bounds exception. What about this next one? Right, it had to be null. Okay, it says it has to be a Java literal. That narrows things down. I was thinking you could just put like division by 0 or something in there and they'd all do it. Yeah, we have to set the S to null and then we can't take its length. Speaking of division by 0, what's the answer to the next one? 0. And what about that? Just about anything. So let's just make the string x. So if you store the string x in that variable, which is perfectly fine because it's declarative type object, so it can contain any object. What's going to happen when you try to cast it to an integer? Yes, the class cast exception. It won't be allowed. Okay? Yes? Yeah, 0 would be, you give -1 as an answer, or 100 or 1,000,000 or whatever. What? Say a little louder. A string wouldn't compile. So then we would have to have a debate when we grade it. I should have said here, give an literal which will compile, but will cause an expression to be thrown in. Yeah?
Can you parse an integer out of a char?
Parse an integer out of what?
A char. Character. Will it give you like the Unicode?
Yeah, I mean, you can convert, you can cast a char to an int. A char is actually it's a 2-byte int, it's a short integer. You can add chars, subtract them, and you can store one in an int variable, and you just get the Unicode value. Any other questions? Okay. So this exam ends with 1, 2, 3, 4, 5, 6, oh my, 7, 8, 9. Wow. I don't have the patience anymore to grade that many lines of code. But we'll look at them, see how far we get. Wow. I think when I made this exam up, I must have run out of ideas right about question Q. Okay, so we want to get the largest number in the non-empty array numbers. So we get an array of numbers, array of doubles, and we're supposed to return the largest. And we know it's non-empty. Now, I asked questions like this on the midterm, and they turned out, I thought I was being all clever by giving you 4 boxes to put the answer in and how that we could grade them each independently. And it turned out that if you answered the question the way I had in mind, it worked out great. But if you had a different approach that was still correct, it was a nightmare to grade. So I've got to hone my craft yet again. But what could we do to do this optimization loop? What should we initialize max to? It's tempting to say 0, but there could be negative numbers in the array. It could be all negative numbers, and then we give 0 back as the answer. That'd be wrong. Yeah, so when it says that the array is non-empty, that's a clue that you can safely just use numbers sub 0. And in fact, the way I've written it, you have to, because the loop starts at 1, not at 0. So if we don't let number 0 be the starting value of the optimization variable, then we're never going to see it. Okay, then we go through, and what do we do? All right, so if numbers sub I is greater than max, max equals numbers sub I. And what do we return at the end? Max. Okay, that should be pretty familiar to you by now. Question, yeah?
The first line where you say double max and which number is sub 0, instead of saying max, could you just do like, I forget what it's called, it's like the minimum.
Okay. So he's asking, suppose right here instead of max we had stored integer dot min value. I think that's how it's spelled, which is like, or I guess it wouldn't be integer, it would be double, which would be the smallest possible double. Would that work? Yeah?
It would work if I started at 0.
Right. If we were iterating starting at 0, that would work. But since we're not, if you had an array like this, let's say you had 10 followed by 1, 2, 3, if we use this approach, we would never see the 10 and we'd return 3 as the answer. So I did it that way so you would have to put numbers 0 up there in that first blank. Any other questions? Okay, is boring. Wow. Returns true if every row in the array contains the same string and returns false otherwise. You may assume that A has at least one row. All right, how do we do that? Well, let's start. What kind of loop is this here? It's a for each loop, an enhanced for. So we're going to pull the strings out of the array. What do we put in the first blank? A. So for each string in A. So now we've got, how do we decide? What we're basically doing is searching for 2 strings that are different. If the array contains 2 strings that are different, then we will return false. But all we've got is this S right here. What can we compare it to? Okay, she said look at index 0 of the array. There's guaranteed to be an index 0 of the array. So if not, S dot equals a sub 0. So if they're different, we return false. If we never find anything different from A0, we return true. Now, is that good enough? Could there be an array that we miss? Because we're always comparing to the first element. So could we have something like, let's say we have X here, A, B, C. It's going to find it, right? It's going to compare the A to X and find the difference. Okay? Can you think of a situation where it wouldn't work? We're always comparing to the first element, backfires on us, yeah?
If you had an array that was XABA, then...
Well, XABA, well, that is, okay, so what would be returned, true or false? We return false because X and A are different. But what should be returned? False. You only return true if everything is the same. Right? What if there was only a single element in the array? It would end up comparing X to itself once, and it would return true because the loop would end. So this does work. A little bit tricky, though. Any questions about it? Okay. This says it returns the number of distinct strings in the array S. So we got an array right here, and I want to get back the number of distinct strings. So for example, up here, there are 3 distinct strings, A, B, and C. A occurs twice. So I want the number 3 back. Okay? And there's a hint here, this word set. So what's a simple way to get rid of duplicates? You put them into a set. So we'll say, like, we'll make a hash set of string. And how are we going to construct this thing? What do we pass as a parameter to the constructor? This is expecting you to know a method, a constructor that you may not know, by the way. Because that's the problem with using O exams. It turns out that you can pass an array into the hash set, and it'll just add all the elements to the hash set. No, I take that back. That'll work with some things, but not with arrays. Okay, we create an empty hash set. Now what do we do? What do you think we're going to accomplish with this loop?
Fill the hash set?
Yeah, we stick them all in the hash set. So we're going to say set.add s. So now we've thrown every element from the array into the hash set. So how do we determine how many distinct strings there were in the original array? Yeah, it's just the size of the set. So we return set.size. Okay. Any questions about that one? I'm going to skip ahead to make sure we hit some that come later. Let's look at this one. So this is the link class that we looked at last time. So we got a class called link. It's meant to be a node in a linked list. So it has a value and a reference to the next thing in the chain, or null if there is no next thing. We have the constructor here that it initializes the link with a value and a next link. We can get the value and we can get the next link. Okay, so those are our 2 methods. So look at that for a minute. Got the constructor and the 2 methods. And the picture in your head is a given link is going to be something like that, or maybe something like that, depending on whether next is null or not. And we got a way, given a link object, we can extract either piece. The value, which is B5, and the link, which is the next. Okay, this is a recursive method that returns the length of a linked list. So This one here has a length of 3 because there are 3 links in it. Here's the picture. Oh, I don't think the picture made it into this copy. So what would the picture be? I'll draw it for you. Okay. Forget about the code for a second. You got a list like this. How would you describe its length? Look at it this way. Here you have a link that has some number in it, and then another link. Describe the length of the list of which this link is a part. Describe the length recursively. It's one thing to say the length of a linked list is the number of links it contains, which is correct. That's more of an iterative definition. Yeah? Right. It's one more than the length of the list that starts with the next element. So in other words, the length of this thing right here is 1 plus the length of the rest. Same thing down here. The length of this whole mess here, and I haven't shown you what lies beyond, is 1 plus the length of what lies beyond. Okay? So that's the recursive case. That's the key thing to figure out, to get the recursion, is to realize it's one more than the length of the rest of the list. Okay. What's the base case for the length of a linked list? What is the base case? Yeah. Null is the base case, and that has a length of 0. Okay. So with all that in mind, we've got the base case to fill in right here and the recursive case to fill in right here. So what test do we do to decide if we're in the base case? Okay. If list is null, what do we return? 0. And otherwise, we return 1 plus what? But what do we decide? It's the length of the rest. So we need to call length, and how do we get the rest? List.getNext. I don't have room to write it, so I'll write it here. Okay, that's kind of a hard question. Because I'm taking one topic, recursion, which is hard enough by itself, and marrying it with something that we just barely talked about last time. So maybe in 2014 I spent more time on linked lists. Yeah?
So could you also do if list.getNext equals null, return 1 for this case?
Wait, say that again. If list double equals what?
If list.getNext double equals null, then return 1.
Yeah, you could say if list.getNext. So if list.getNext double equals null, then return 1. But that leaves out the case when you pass null to that thing. You could add a second base case, but it's not necessary. Just use a recursive case. Any other questions about that? Like I say, I'm not going to ask you a question like that. Yeah?
Recursion will be on the exam though?
Yeah. Well, recursion is eligible to be on the exam. I haven't made the exam yet. Since you ask, I'll make a note. Yeah. Recursion. All right. Any other requests? Okay.
You should just have us code now.
Hmm?
Code the whole asterisk.
No. Okay, this is the same example list. It keeps promising the thing later, and it never comes. I think what I had to do was I actually had to draw the thing in on the original. Somehow it didn't make it here. But anyway, now I want an iterative method to determine the length of the list. Now, I want to return the integer that's in the last link. So if I've got this again, 8, 9, 10, I want to get the 10 back. This should return 10. If I pass a reference to that link, I should get 10 out. Okay? And we're assuming that we're not being passed a null right there. So, someone already sort of said the answer on a question. Who was it over here that asked that? About the changing the base case before. Yeah, how can you tell? So the idea is we're going to walk down the list. Right? We start to here. This is our first reference. Then we go to this reference. Then we go to this reference. How do we know when we've gotten to the end of the chain? Right, when list.next is null. We can't wait until list itself is null because then it's too late. We've gone off the end of the list and we don't know what the last value was. So while list.getNext is not equal to null, the job of the while loop is to walk down the list. So what should we change list to? So we found out that this link did not have a null as its next element. So what should we change that variable to for the next step? Right, list becomes list.getNext. So the next time through the loop, list will be pointing at that. And the time after that, it'll be pointing here. And then list.getNext will be null and the loop will stop. And then what do we return? List.getValue, we return the 10. Okay, so those two questions show you doing things recursively versus doing them iteratively. Okay, this probably going to be, definitely going to be the last one we can talk about. So we're implementing a set called restricted int set. Basically, what that means is you pass a positive number to the constructor, like 50, and that means the set will only contain the numbers 0 through 50. That's the restricted part. So it can't contain any int, only the ones from 0 to 50. And we're representing an int set as an array of booleans. And to make the comment here explains it, but here's the idea. Suppose you had an int set where the max value the values went from 0 to 4. 0, 1, 2. So there can be 5 possible values, 0, 1, 2, 3, and 4. How could we use an array like that, where the values are booleans, to represent the set? How can storing trues and falses into an array represent a set of integers? Here's an example. What's the trick? Yeah.
You can just say, like, if it's true, then that means it's in the set. If it's false.
Right. Right. So let's say we're trying to represent, this is what he said, a set that contains 0 and 3. What we do is we store a true in the 0 index, and we store a true at the 3 index, and with falses everywhere else. So the trues tell us which elements are in the set. So the indexes, the integers that index into true are in the set. And the ones that index to false aren't. So this is kind of a weird way to represent a small sets where you know the maximum value. Okay? And you can see what's happening here. To add an element to the list, to the set, we just set member sub n to true. To add n into the set, we set member sub n to true, assuming it's in range. To remove, we just set to false. And I don't have time to do these methods. Let's just talk about this one and we'll stop. This is going to create a restricted int set with a specified maximum value. So what would you have to do? What would the constructor have to do? How would you build the representation of a set, an empty set? Let's say max value is 10. What would you have to do to create a restricted int set to represent that? It's only one instance variable, yeah.
Make a new array that has indexes 0 through 10.
Right.
And make them all false.
Right, so what we would do is members is our instance variable. We would say members equals new Boolean of max value plus 1. That's what would, this is what would go there. And then what's the loop for? It stores all the falses to make it empty. Okay, so that'll give you a leg up on understanding a couple other methods that are in there. So we'll stop there. It's been a great semester. Have a good finals week. I'll see you toward the end next Thursday.